So this one is about Le Chatelier's principle, and this is how you manipulate equilibrium to give you more of what you supposedly want. So the three things that I'm going to use, or that I'm going to manipulate this equilibrium are concentration, temperature, and since the reactants and products, since this equilibrium contains gases, I can also use pressure. So these are the three things that also determine rates of reaction. So that's kind of why it works, is because I'm going to change the rate at which this reaction takes place to favor one side or t'other. Now, in terms of concentration, I'll do that first. I'm going to increase, let's say I increase the amount, the concentration of NO4. So to this equilibrium, I'm going to shoot a little extra N2O4 into it. And what's going to happen is, when I bump the N2O4 up, there will be more N2O4 present, and so that's going to increase the rate of reaction. That's going to shift it to the, there's going to be a shift to the right. Another way to say that is the products are favored. Or another way to say that is the forward reaction. Forward reaction is favored. So all three of those mean the same thing. The outcome is I'm going to get more NO once equilibrium is reestablished. Okay, so concentration increasing into, turns out I end up with more NO. So increasing the N2O4, I'm going to get more NO. Now, if I went the other way, okay, let me get rid of these arrows. This time, I'm going to decrease. So this time I'm going to decrease the amount of N2O4. So I'm going to drop that down. What's going to happen now is the equilibrium is going to shift in the other direction. So instead of shifting right, it's going to shift left. Instead of the products being favored, we would say the reactants are favored, because there's going to be less. And then instead of the forward reaction being favored, we would say the reverse. Okay? So it's just opposite. So that's when I'm fiddling around with concentration. Okay? So let's get rid of that. Let's talk about temperature. Remove all that stuff. Okay, so we just got rid of concentration. Get rid of these guys too. All right. So in terms of temperature, since I have a delta H right there of a positive 57.2, that's an endothermic reaction. Endothermic, as read, left to right. Left to right. Okay? Now, because these are reversible reactions, that also means that there is an exothermic reaction if I read from right to left. All right? So, in terms of what's going on, this is endothermic in this direction, and it would be exothermic in the opposite direction. So that's kind of important. Now, what's going to happen if I increase the stress that I'm going to apply, Le Chatelier's stress in this case, I'm going to increase the amount of heat, or I'm going to increase the temperature at which this equilibrium is taking place. I'm going to increase temperature. Well, increasing temperature is going to favor the endothermic reaction, because that's what an endothermic reaction wants. It wants energy. So if I increase temperature, I'm increasing energy, and I'm going to give the reaction exactly what I want. So what's going to happen is I am going to end up shifting the equilibrium to the right. Okay? In other words, I'm going to increase the concentration of the NO2. It also means that the forward reaction is favored. All of those things that I, talked about, favored. And I'm going to end up with more, once the equilibrium is reestablished. Okay? Now the opposite thing is going to happen if I decrease temperature. If I wouldn't, then that's the nice thing about equilibriums. If I go the other way, if I decrease temp, then it's no longer shift to the left, it's going to be, or no longer shift to the right, it's going to be, it's all going to shift to the left. Okay? So there's going to be a decrease in the, there's a decrease in the amount of NO2, because what I've done now is I've shifted this equilibrium in this direction, right? Because I'm decreasing temperature, and it will no longer be the reverse reaction that's favored, or the forward reaction that's favored. It's going to be the reverse reaction that's favored, right? Okay, last one is pressure, and pressure deals with the number of moles present. So, oops, didn't want to raise pressure. Oh well, I'll raise it anyway. Let's clean this all up. Okay. So, okay, here we go with pressure. As I read this, the coefficients tell me that there's 1 mole of reactant and there's going to be 2 moles of products. So when we're dealing with pressure, it all has to do with how much space this equilibrium is taking up. Each individual reactant or product is taking up inside the reaction container. So if I increase pressure, on this equilibrium, what's going to happen is it's going to shift to the side that takes up the least amount of space. So it's going to shift toward fewest moles. And that means, okay, it's going to shift to the left. The reverse reaction is going to be favored. The N2O4 concentration is going to increase because of that. And again, with equilibriums, if I do the opposite, okay, if I decrease pressure, I'm going to now shift in the other side. Decreasing pressure is going to shift towards the side with the most moles, which means it's not going to be N2O4, but it's going to be NO2 that's going to increase. All right? Try that.